Welcome to AI with Justin. If you've used Chat-GPT, maybe you've been impressed, maybe you've thought this thing is dumb, but you've definitely thought, how the hell does this thing work? This video is intended for people with no or very little technical AI knowledge who want to have more than just a surface level understanding of modern AI. The first half will be mostly concepts, and the second half will connect those concepts to the context of ChatGPT. Firstly, how can something without a brain become intelligent? Well, it seems that intelligence is the result of simple things acting together to make more complex things, like many water molecules together forming a wave, individual, relatively simple ants together forming a complex colony, or employees, each with their individual incentives, forming a company that has its own incentives. These are each examples of the concept of emergence, which is the base abstract concept from which intelligence forms. We humans have brains. Brains have lobes, each with different functions. These lobes are composed of neurons, and neurons are composed of organelles, which are composed of proteins, and so on. If we examine these smaller components individually, such as an individual protein, they wouldn't appear too smart alone. But as a whole, they end up producing human intelligence. So that's an example of how biological intelligence emerges. Artificial intelligence arises in a comparably emergent way, but unlike biological intelligence, there is a more pronounced and abrupt division between two domains, hardware and software. Most of the properties we think of as intelligence emerge in the domain of software, which is built upon hardware. I'll address hardware and this division before moving on to the core of how intelligence emerges artificially. Modern hardware is the physical component of machines. It can be very complex, but we really don't need to understand how it works in depth, because the result of it all is support for representation of the binary system through instructions and data storage. And the simple binary system can actually be used to represent any other type of system or information management. For example, the chart to the right shows binary representations of decimal numbers. And if we want to represent letters, we could come up with mapping of particular numbers to letters. In fact, we could come up with a sophisticated mapping of binary values to anything, really. In practice, the binary system is mapped to programming languages, or software. These programming languages are designed in ways that allow humans to flexibly and more easily write instructions for the machine. And this is the base level platform in which modern artificial intelligence is built upon. Okay, so what kind of crazy programs are humans writing to make something like ChatGPT? How do we go from instructions and data management to intelligence? While there are many important topics contributing to ChatGPT, there are two main ones that encapsulate the basics of how it all works: machine learning and neural networks. I'll introduce machine learning first. Before machine learning became popular, researchers used to explicitly tell machines how to behave using sets of rules. For example, if a rule-based AI was playing chess, it would have a set of instructions like, if this configuration of pieces occurs, then make this specific move. This worked for simple tasks, but proved difficult to expand upon when tasks became even moderately complicated. For example, if you wanted to write instructions on how to identify all birds from video pixel data, how long do you think that set of rules might become? Consider the angle you're viewing the bird from, the lighting, the background. Is this a bird? Hint, the list gets pretty long. Too long to show a promising future as an effective way to build greater and greater intelligence. So instead of explicitly giving AIs instructions, researchers found a way to allow AIs to sort of write their own instructions. This process is named machine learning. Machine learning works by incentivizing an AI to maximize some score. This score is often called an objective function. A good objective function for a chess-playing AI would be to win as many games as it could. So now imagine a chess-playing machine learning AI. It tries a few moves, observes the outcome of the game, and depending on how it did, changes its strategy. If it did well, or in other words, if it scored high on the objective function, then it tries to do more of what it did that game. And if it did poorly, then it tries to do less of what it did. It keeps playing many, many games, observing many outcomes, and updating its strategy. That somewhat straightforward trial and error process I just described is the essence of machine learning, and is usually called the training process. But there's important details to be considered, such as if an AI wants to change its behavior to do more or less of something, how exactly does it do that? How does it know what to change? And how does it apply these changes? Is it just random trials? Trial and error, as humans know it, is driven by some form of logic, right? Spoiler alert, it is not random, but to understand it, we're going to need to take a detour to talk about the design of the AI itself, which, for modern AI's core, is composed of neural networks.